Good afternoon. My name's McKenna. I'm the technical head of the utilities team here at 1Spatial. And today in my presentation, titled Solutions for a Safer, Smarter and More Sustainable World, I'll be looking at the importance of good data governance and how, through targeted solutions, we can look to unlock further value from our spatial information. I've broken my presentation down into three main topics. First off, I'll be addressing some talking points. Seeing data as an asset rather than nice to have. How, through effective use of data, it can enable our workforces and return valuable insight into our networks. And how data can be used as a tool of management, inputting into our critical business decisions. My next topic will be some value points. How we can unlock the value of our data through good data design, effective data governance, and the standardization of data rules. Finally, I'll be showing some demonstrations of 1Spatial targeted solutions that unlock the value of locational data. To start off, we must start recognizing that our data is in fact an asset rather than a nice-to-have piece of information. Utilities are amongst the largest holders of real-world digital data. And by real-world, I mean the digital records that we hold in our repositories are representative of real-world assets, i.e. a line within our GIS represents a pipe or cable in the real world. This, to me, is why digital data is one of the most important assets that a utility has at its disposal, as it allows us to create a single view of our entire network, which in real life often span across vast amounts of land. The reason these GISs have been adopted is because it is recognized as a key tool for critical decision-making practices, as it allows us to derive insight into our networks, both in real time and learning from historical. This to me is why the value of data is completely real and entirely measurable. And that is why it is important that we must start treating digital data as the valued asset that it is. As we move into a digital future, the accuracy of this digital data will become pivotal to our success as organizations. So how can we use the data to enable our workforces within our organization? Well, first off, we must ensure that the data is working for us, not the other way around. Continuous manual management is intensive and not always the most accurate. And unlocking data's value will be the key to finding the efficiencies utilities are searching for, such as operational efficiency, increases in customer satisfaction ratings, compliance with the regulatory demands, and importantly, enabling the return on our large investments. To achieve the latter, though, it is important that the data must be accessible enterprise-wide. Utilities have long recognized the restrictions of locking data away into things called data silos. However, at the time, it was considered one of the only methods of protecting the integrity and quality of that information. However, to achieve this enterprise-wide accessibility, while also maintaining data quality and integrity, automation is the key. Automate to facilitate, to ensure maximum use of that data across your enterprise, maximize the return on investment and the value of that information. And that drives us nicely into data-driven management processes, unlocking data within our organization while also controlling the governance of it. With the utilities I've had the pleasure of working with, who adopt this mind frame, such as NGN, as demonstrated by Liam earlier today. They adopt a continuous improvement mindset, unlock the value of data while continuously learning and improving it throughout our enterprise. After all, digital representations of our networks is a proven and effective way of management. And as utilities are being tasked with finding further efficiencies from both their physical assets and from the valuable commodities that we entrust them to transport and supply, these digital representations will be critical. Having worked in the industry for a fair few years now, I think it's a general agreement that the movement towards automation of data management, the construction of digital twins, and the adoption of emerging technologies such as machine learning and AI is the direction the sector needs to be moving in to enable it to grow and succeed. But in addition, these technologies also allow us to make better use of multiple information sources, both real-time and historical. This will be critical as this will allow us to drive further insight into pattern interpretation, recognition, and the identification of anomalies, allowing us to move to a predictive model rather than reactive, and in turn, creating the holistic AI operational platform. So we've talked about some talking points on recognizing that value, but how do we achieve that? And this is where 1Spatial, having an extensive history of successful data management, have three core pillars that underpin the integrity and trustworthiness of your spatial information. I have summarized these below. First off, spatial integrity, ensuring that geometries are valid, that the spatial features of that feature itself is valid and is within the design constraints, within the standards set by your organization. The second integrity piece is non-spatial integrity, ensuring that attributes are valid, that domain properties are correct and relationship properties are correct. Non-spatial integrity can sometimes get overlooked, but is critical to the full integrity, full connectivity of a network. And finally, connected and integrated. Is your network fully connected? Is it integrated effectively with other systems so that value may be maximized? Is it complete? And any changes that happen on that network, are they effectively managed? Mastering these three key components will set you on the right path for spatial success. But it is just that. It is a long, continuous path. Because data governance cannot just be a project. It must be a process, a mindset. After all, data governance is the foundation upon which effective data is built. And one key component of this is the ownership and accountability given to our business. Individuals or groups who are assigned to be accountable for certain sections of our data must be held to it. However, this can be a daunting task if tackled manually, and this is why the adoption of automated rules to enforce standards such as data quality must be explored. The creation of a continuous improvement cycle, the management and, more importantly, effectiveness of our change control processes. All of this, adopted in an automated fashion, will mean that we can maintain our data integrity while also allowing further accessibility and transparency across our enterprises. Now, this leads us into our final talking point, the importance of data standards. Data governance must follow a standardization rule set. Not only does it give us a bar to shoot for, but it also allows us to identify pre-existing non-compliances and prevent new ones from entering. This allows us to almost maintain that integrity level, the one that we achieved at the end of our data definition programs. Now, to do this, in an area that 1Spatial work intensively with our clients, there must be a set of defined rules that allow and govern such things as data access and data definition. The automated approach also allows us to frequently test that data set, ensuring that information that does exist within our estate is compliant to those defined quality standards, building on that trust in information. And all this trust adds up to a key item: use of that data in business making processes. If we trust the information in there, we will trust that our decisions are correct, and by and large, the implications of our decision makings will be positive. And that leads us into the 1Spatial location master data management. For this process, 1Spatial understands that your enterprise data is one of the most valuable assets that you have at your disposal. So therefore, it must be protected and its quality assured. However, as previously mentioned, it is also important that that data can be used across your organization, not just siloed away. And therefore, 1Spatial's location master data management process allows both of these to be achieved. There are 4 critical points in the 1Spatial location master data management process. These are cleanse. This process measures the quality of your information, ensuring that those data standards described before are adhered to for all the information within that enterprise data set. Match, to ensure integrity of both the data, but also integration with other systems, allowing that enterprise data to flow across your enterprise and interact with the systems that it needs to. Synchronization, this is that continuous improvement cycle process that I previously described. And analysis, allowing the information that is now cleansed, matched, and synced to be used in business processes and trusted that the results achieved via that process are accurate and reflective of the real world. This is critically important, particularly for the data sharing initiatives that are entering the utility space. Utilities must and need to be able to supply information to these data sharing platforms and trust that information is fit for consumption within those platforms, reflective of the real world situations. After all, the real value of your data is how you use it. One example of recognizing the value of data on how you use it is the Esri utility model migration. 1Spatial, as spatial data experts, have built a 3-stage program to help utilities make the migration from Esri's geometric model onto the new utility network model. The 3 steps are as following. First, data preparation. Data preparation is key to any data migration, but in particular, the Esri utility model migration. We need to ensure that the data in the existing model, the geometric model, is cleansed and accurate. Where there are non-conformities, they are enhanced and corrected. The system is a fully connected one and is complete. Once stage 1 has been completed, and we are happy with the state of our geometric model, we then look to migrate it into the utility network model. This will involve a design of the model itself, one that is fit for purpose and ready for use once implemented. We then need to transform through a series of algorithms, moving the data from geometric model into the new. We then need to relate that data to ensure that existing relationships hold from the geometric post-migration. But importantly, it must be an iterative process, taking parts of the network at a time. Migrating the entire network at once will likely cause more issues than have benefit. And finally, stage 3, the integration piece. This is where, as per my previous slide looking at the location master data management theorem, we follow a very similar approach. Synchronize, ensure the information that we have now deployed into the new model adheres to the same data standards that we held it to as an organization in the geometric. This will involve repeating certain things, so the cleansing, the corrections, the completeness, and the connectivity. Then there is an integration piece, ensuring that not only is our GIS sound, but the connections to the reliant systems, ensuring that data is ready for maximum use across our enterprise, integration with systems such as SAP. And at the end, we hope to have a single source of the truth, protected by 1Spatial's location master data management. My next example of how we can potentially unlock value from our spatial data is looking at the 1Spatial Traffic Management Plan automation tool. This tool looks to automate the practice of creating traffic management plans for utilities. These plans are required when a utility needs to access assets lying beneath roads or public footpaths. As Clive mentioned earlier today, Northumbrian Water alone excavate in public highways approximately 100,000 times a year. But the time it can take to produce these plans can be lengthy and expensive. So therefore, 1Spatial have created the TMPA solution. This looks to take the creation time of these management plans down from days to minutes, as demonstrated in the video. As the creation is also automated, following a consistent production route, they can be trusted to be compliant with industry regulations, ensuring the safety of both the engineers on site and the public road users. It also enables us to have a positive impact on our customer satisfaction, as we are able to target addresses impacted by our presence in the road, enabling us also to identify vulnerable customers, ensuring that their needs are met during our time occupying the road. And with less dependency on site visits, as we are driving the map through spatial digital information, it also assists us in meeting our green objectives. Next example, and one that is particularly reliant on good data governance and good data accuracy, is the 1Spatial machine learning. For the example here, and the demonstration video you see on the left, is one focusing on a big challenge facing the water industry, leakage. For this, 1Spatial have built a predictive spatial machine learning and rules-based tool to identify the propensity or likelihood of a pipe to fail. This, in turn, is aiming to identify likelihoods of pipes with a high chance of failing pre-event, allowing utilities to be preventative rather than reactive. The model is constructed from a series of pre-processed and parameterized datasets, which means the model is ready to be trained on your data. The model is adaptive, meaning that when there are real-world changes and these are updated within your GIS, it'll recalculate the propensity scores based on each iteration. The hope for this platform is that it will allow utilities to unlock further value from their data by deriving predictive data insights, and being completely expandable, further analytical approaches can be added, such as the effects of water consumption. However, it is critical that the underlying information that these models are built on are accurate and reflective of the real world, to give the machine learning program the best foundation to build on, to learn, and to provide accurate insight. My final example of unlocking value from spatial data is the 1Spatial PAI solution, looking at improving positional accuracy of our assets. After all, ensuring the positional accuracy of all our data, making sure it's fit for purpose, is a critical part of unlocking the value of that data. Therefore, 1Spatial has built a powerful transformational algorithm in its product 1Integrate that can automatically adjust the position of your data, something that otherwise was traditionally a manual shift vector based process. However, PAI goes a step further, as shifting networks can cause issues further down the line. The way that 1Integrate is constructed, it allows it to build its own topology model representing the network in your GIS, meaning that when that information is copied back, the topology is maintained along with any feature relationships that exist in your data. This makes the PAI solution a hassle-free, effective, efficient, reliable, and automated process that can work in the background, quietly improving your data standards. Thank you for your time today. It's very much appreciated. I hope you enjoyed my presentation, and I will be in the lounge should you wish to discuss any of the solutions that you saw here today further, or if you would like to discuss some of your own geospatial challenges. Thank you again, and enjoy the rest of your day.